Professor Hoi Zoho, Mr. Wilfried Steve, Mr. Sibaniso. And if you're here, please do raise your hand so that.
Just in the interest of time, we must just start. Give it another 2 minutes, I think.
Yeah.
It's 5 past.
I think one is here. And I have marked, yeah.
There you are.
Yeah, that page.
I'm waiting for you.
Professor Tokozoin? Yes. Yeah, please welcome. Yeah, you can just please be seated.
We'll work from here for your presentation.
Yeah, you can be here.
Yes, I know.
Welcome, please.
Go to the toilet first.
Oh,
We try to move it, and we're going to allow only questions at the end because we are far behind.
we're running out
Oh,
of
so
time.
what will happen? We'll just sit here.
Sit here and we'll call you out one after the other to do your presentation.
Let me just go to the toilet.
Do that.
Yeah, please go.
That's the new style. I like it.
Thank you.
We talk a lot.
But there should be someone to listen to us, right? But it happens, but not to this extent. Not like that, not like that. Shall we? So, I think I can introduce you. So, begin. Okay. Whom do I address?
Just start. Here they come.
Yeah.
That's the cleaners.
Very unfortunate, right? I think they'll be back. So it was more than an hour. So I think they need some space. Yeah. I hope people will join us soon. This is the co-chair, Dr. Sendil, for this session, and I take the privilege of introducing the chair of this session, Professor Kobos, a prominent figure, a civil engineer by profession, and he holds the position of head, Department of Civil Engineering at Stellenbosch University. He's also a part of various professional organizations, which include South African Institution of Civil Engineering, a fellow of Institution of Mine Engineers of South Africa. So his work includes water and environmental engineering with a specific focus on flood control and drainage system. We are really fortunate to have him here with us today, and I now invite him to present his work.
Thank you very much. All right, all 6 of us are going to go through this fairly quickly. Try and make the best out of this. So, ladies and gentlemen, I just assume that after I've made some comments to the minister, no one wants to listen to me anymore. And I don't blame you. It's a rare opportunity. But nevertheless, what I would like to introduce to you is a fairly quick page through what the title is saying, a best practical guideline for design flood estimations in municipal areas in South Africa. So I'm not alone in this business. There's our guideline on the left, and I've got a whole team that work together, 4 different academic institutions, 2 from private practice, and we've come up with this guideline for a specific purpose. And I would like to present this for us in the context of give a bit of background, then the content of the guideline. I really am going to just page through all those different chapters, just to make you aware of what was done and what is available, and then we can take questions afterwards. I don't have to say anything further about the capacity at local authorities given our previous session. But nevertheless, from the specific National Sanitation and Master Plan, it was clearly stated that 63% of all our water infrastructure at local authority level, that's 163 out of the 257, is in serious need of help. Whereas almost 30%, 66 of them, are completely dysfunctional. And given this state of the situation, we as ICEES, the Institute of Municipal Engineers of Southern Africa, join hands with the Water Research Commission, and we've compiled this guideline to enable us to provide some background information to guide the local authorities to make some decisions in the flood space. Do I have to say anything more with my next comment on the slide? The question's been asked, will political leadership be part of the solution or part of the problem? And that's why we are now tackling councillors, trying to sense them with this guideline to help them making the right decisions. So what is a design flood estimation? First of all, it is a size, cubic meters per second. It's the magnitude of a flood with a certain risk attached to that, the exceedance probability. And that exceedance probability demonstrate risk. What are you prepared to design certain infrastructure for? In layman's terms, we refer to that as recurrence interval or return period, of where we would say, if we talk about a 100-year flood, we are talking about a 1% probability that it will occur. It's not an observed event, it's a design event, and we need to come up with these figures. And you might have listened to my comments previously about climate change, is all of these models is fine for us, but as engineers, we need to design infrastructure, and we need to do that in the context of the circumstances of the time, which include climate change. So we use those design flood estimations to design and do risk assessment of hydraulic structures, dams, stormwater systems. We use them to draw up flood lines, which guide decision-making regarding planning and development at local authorities. And we use those numbers to show and manage flood inundation to prevent people from living in areas that's probably been flooded for long periods of time. The reason why we've got a problem, besides the big challenge in terms of the people at local authority level, is our data. And what you see there in the black line is the situation of the workable rainfall stations in our country. I don't have to explain that to you, but before 2010, we were already down to the levels what we've had in 1920. It's not a good story. The river flow situation is similar, but not as bad. But nevertheless, we were in, just before 2010, we were already down to stations at the level where we've been before 1980. So we are losing information at a significant level. So in the context of that, the Water Research Commission and ICEES joined hands, and we appoint a guiding group that can guide us through all this decision making. And we try to focus and make specific objectives in trying to address the technical capacity deficit, particularly in the smaller municipalities. You know, the engineer working there is a loner. He is probably only supported by 2 or 3 people, and he must make or guide these decisions. We try to provide some guiding principles for him to assist him in doing that. We want to review all our flood design calculation methods in South Africa in this guideline, and we would like to consolidate the available information in a one guideline document that is easily accessible. So our guideline consists out of 10 different chapters, and in those chapters I'll page through them one by one fairly quickly, and a lot of appendices that I would like to make you aware of what information is available for us in those guidelines. So on the right top, you will see where I'm more or less in the guideline. We are in chapter 1, and we try to address how to use the guideline and what is the scope of the flood estimation. The whole intention of the guideline is to assist municipal officials. We are talking mainly about the engineers to carry out their flood management, but also the disaster management team and the planners that needs to plan for new developments. We want to put on paper best practices for design flood estimation at the municipal level, and we select methods that's mostly being used in South African municipalities to assist us in doing that. They are suitable for urban and municipal catchments, not for our big, large catchments that the Department of Water and Sanitation are typically working with. We also, in this guideline, emphasize the responsibility and accountability of the municipal manager. By now, you've listened to all of my stories, but we've got a serious problem in the local authorities, and our legislation addresses these issues of the municipal manager in the context of flooding. We emphasize the fact that it's there for the urban stormwater management as a resource and minimizing the impact of our urban developments, and we frequently use the undeveloped area as a reference point to try and see how will that be impacted. Furthermore, we talked about the expert knowledge that you need in order to do flood design. But municipal officials, people that's taking those decisions, need to have sufficient understanding of the science. Otherwise, they would not be able to be of value to the municipality. But if they don't, then at least they must know when to seek help and how to seek that help and support. We help in the guideline, help to refine the understanding of the good practices. I'll talk about good practices in South Africa, what it entails, but it expects the user to have at least some sort of basic principle of the science. We must get the message across that any changes in land use, and that's specifically important for the municipalities, any changes in land use and land cover will change the flood response. And every time the local authorities approve a new development, they must know they will change the response, and they must cater for that. Urban densification, I don't have enough time here, but if you see how serious that problem in South Africa is in terms of people that wants to live close to water resources and our rivers and close to our towns, then it's a major problem for all local authorities to make sure that as our urban space densificate, then we also need to take note thereof that it will result into specific increase in flood responses. And then, of course, flood lines, we make a point in the guideline about that, is not cast in stone. It changes regularly, and you have to update that to make sure. We emphasize the catchment changes, how they change the flood response. We talk about flood lines and stormwater management and how that needs to be dealt with at the regional and local planning. We really need to work together in the different departments if we want to ensure that our people, on our habitants, our citizens, are not exposed to these floods. There are a strong link between the urban planning, stormwater management, and disaster management that is so prominent at the moment. We all say it's climate change, but it's just simply disastrous management. We should do better than that. So the second chapter deals with the legal framework, and there is in South Africa a proper legal framework. We take it right from the Constitution, right through the bylaws that's in place, and we emphasize the fact that the municipality, to ensure that we've got proper flood management, with reference to our guideline that we provided there, must at least have good bylaws in place. If you don't have the good bylaws in place, you cannot enforce or make sure that you implement regulations. You have to have them in place. We also make the point that municipalities remain legally responsible and that they need to have, and they probably will have to explain in court, there's a court case now in eThekwini here about that, that they have taken the reasonable steps to ensure that everyone has been safeguarded against floods. Local authorities doesn't want to hear this section, but that's unfortunately part of the legislation. In Chapter 3, we deal with the introduction of flood estimation principles. We look towards what needs to be included in those guidelines. We talked about the design flood estimation requirements in terms of that it needs to be a professional registered person that do this. When I do these presentations, I jokingly say, I hope I'm joking when I say that when a student of mine graduated from me and he's been appointed to do the flood lines within 2 or 3 years, it's a disaster. We need to have experts to do that, and he must still learn that process. So by the way, if you ever see a calculation of a flood like 100.7657 cubic meters per second, know it is someone that doesn't know what to do. We are guessing so many things that if you go to one decimal, you certainly doesn't understand the principle of flooding. We need to, at a local government level, agree on the level of expertise and detail that you require to have as input. We need to do that properly in the beginning. We stress the importance in the guideline of not just using one single method, but using a primary method that needs to be tested in a specific catchment, and then look towards secondary methods to sort of test your input parameters in that context. And we make the point that municipal engineers should consider disaster management implications. Once you've done your flood calculations, it's a risk statement with a flow volume. What if something bigger happened? Do we know the consequences? And that's important to get that message over to our local authorities. Best practice against good practice, we try to make a point in the guideline about that. What is best practice? What information should we know? What methods should we use? Good practice is that all flood calculations doesn't need to follow the same detail. If you do need just a preliminary estimate, then the process is different. It needs to be fit for purpose, and we need to make that point. So floods consist, when you do design flood estimations, it consists of a lot of input parameters. The guideline provide those design rainfall estimates. the different observed flow data, if we can get hold of them, and we refer as these input parameters as the first step, and the guideline spent some time and space in with the different paragraphs being highlighted there in how to deal with this. And then the catchment characteristics, the soil properties, the climate data that we need, the land cover, where do we get this, and how do we feed this into our observed rainfall input parameters to jointly then result to an output, which is a flood peak, using a specific flood determination method. And these methods vary whether they are event-based, rational method, the RMF, of which I'll highlight a couple of them just now. The guideline also provides some broad guidelines. If you are looking, for example, for a development control assessment for small catchments, smaller than 5 hectares, then there are certain methods that you can use. I'm not going to go into the detail thereof, but we do make those recommendations thereof. In terms of Chapter 4 that provides the roadmap, we classify all of these flood design approaches into probabilistic methods. That's not new, it's just how we deal with it in the scientific world. If you do have stream flow records available, please do that. Or the deterministic methods, which can be either event-based, a single storm event, or continuous simulation modeling, which becomes now easily available through the SWIM software. And we didn't select SWIM because we like it particularly, but in South Africa, it's the most used software application to do stormwater management, and we've included for that reason in our guideline. Then we also include the empirical methods. They doesn't have a high reliability, but they give us the upper limits. And in the South African context, we decided to include in the guideline only the regional maximum flood to give us an upper limit of what we should expect in that particular area of interest. We make a couple of pleas to practitioners and in local authorities. Please don't use 10 methods and then just take the average. That's not a good practice. They all have different applications under different circumstances, and you have to adhere to those requirements. I talked about the secondary and primary methods. Always test to see whether you have achieved your main objective. We also make in point D on the screen there the point that if you are using probabilistic methods, you get data and analyze that, you really should not use the data to estimate beyond double the record length. So if you've got 50 years of data, go to 100-year probability, but not beyond that. It will give you too much risks involved with that. Chapter 5 of the guideline deals with data sources and how we get the catchment parameters. And I always say that, look, if you forget anything, and I'm referring here to the South Africans sitting in the audience. I hope there are some of them. But if you are sitting here and you forget anything, everything, just remember Chapter 5. Because in Chapter 5, we provide you with an enormous amount of valuable information, links. Where can you get this data free of charge, and how you can access that? That's really very important for us. Chapter 6 deals with probabilistic rainfall and flood frequency analysis, all the stats behind that. I'm sure you don't want to be bothered with it, but plotting positions, how do we decide on the best probability distribution to fit the data and to make the estimates that we do use in terms of whether it's a Weibull, extreme value type 1, or whatever distribution you would like to use. We use the plotting positions to guide that decision for us, and we explain the process in the guideline. We recently developed a completely new, with a PhD study from someone from the Department of Water and Sanitation. We come up with a completely new plotting position, the so-called ZZ plotting position, and we provide the information in that. Chapter 7 deals with our event-based design flood estimation, and we highlight the different methods that can be used, but also the tools that's available for the municipal engineer to assess and to make sure that we do understand or can do these calculations fairly easily. Chapter 8 deals with continuous simulation modeling. So you know, we are now in the era where we've got the capacity, computer capacity, to do continuous simulation and modeling. And we should embrace that. I know there's quite a lot of pros and cons against it. It's perceived to be quite data intensive. It's perceived to be expensive. It's perceived to be difficult. But if you talk to the practitioners, none of those are true. There are free copies thereof that can be used, some of the software applications. And yes, it does take a bit of time to set up the model, but then you gain all that by just be able to change small changes and test different input parameters like detention ponds, which you can't do with an event-based model. Then, of course, once you've got the flat peak, you still need to get to a flat line, which are the thing that local authorities are working with, and that deals with the flat hydraulics, and the river hydraulics, all the details, the roughness coefficients, the formula that you need to use, they are all in those in that manual in Chapter 9. Getting towards the end, watching my time in Chapter 10, that's myself saying I'm done, but there's still time there. Uncertainty, accuracy, and consistency in our calibration. The big problem with flat calculations, I guess this is on an international level, is if you give the same data to 10 different people, you will get 10 different answers. So how do you decide? How do you go forward? So we try, look, we would like to be on the right top corner. We would like to be spot on. But if we can't be exactly spot on, we at least need to be consistent, left-hand side. We must be careful not to be exactly wrong. That can be a big problem. But left, bottom, we shouldn't be there that 10 answers give us 10 different results. Our appendices include examples of bylaws, agreements with consultants for a municipal official to help us with that. I'm not going to spend too much time on that. My almost last slide is then, how do we deal with climate change in terms of making this decision from an input parameter in our existing flood determination methods? And when we've written as a pool of experienced people working in this field, when we written this guideline, there was no consensus in our country, depending on who you ask, of course. You know, we just now heard that climate change is the problem, and you know how I feel about this. But at that pool of experts, we couldn't get, we agree that there are no clear indication of what's happening in terms of the extreme events in South Africa. And for that reason, we were worried about the fact that the international tendency is that you should allow for between 10 and 20%, and we end up with scenarios where someone will just tell you, add 15% without justification. So in the South Africa condition, we've decided that we will adjust on the 90 percentile after you've done regional analysis of your storm rainfall. So you are in the upper reaches of your storm rainfall that you expect, that we should use that as a guiding principle to make provision for climate change impacts. We hope that this guideline will assist us, our local authorities in South Africa, to be more focused in what they need to do, and that guideline is available on ICEES' website under training. Everyone is welcome. It's free of charge to guide it. I thank you. Right. So what we are going to do is we are not going to allow for questions now. We would try to not rush through, but try to carry on with what needs to be presented here. And then if there are some other presenters still here, please join us here so that we can know which presenters are available here. So our next presenter is my co-chair, Prof. Senthile. He will take us through his presentation. And Prof. Senthile, can I ask you to just say something about you? I know you said you're not going to, but please add some. Thank you very much.
Yeah. Thank you. So before I proceed, I would like to take a moment to thank the organizers, Professor Lee and Vetri, for having given me an opportunity to be a part of this wonderful event. And also special thanks to my friends from Kerala, my homeland, for always being supportive. So with that, yeah. And I'm sure the chair, you flooded this hall with your wisdom and knowledge. So I'm here to share the outcome of the work that we did with the Government of India. So it's all about looking for alternate water resources in the country. And this fits for any tropical country. There are more than 100 tropical countries. So, and this will fit in for any tropical and to a certain extent to subtropical countries. So this is Sendil Kumar from the Department of Geobiotechnology from National College, Tamil Nadu, India. So is the green one? Or should I press the green one? Yeah. So the problem that we are addressing is the urban water scenario. As we know, like India is projected to move into the category of water stressed nation. Water, once we believed that we are not going to lose water, but days have come where water is typically available only for 2 to 8 hours a day in most of the Indian cities. And it is worsening during the summers, and we get only few minutes of water from the municipal or the corporations. So especially the 4 major metropolitan cities like Chennai, Delhi, Mumbai, and Kolkata, they are ranked as the worst performing cities in terms of water availability per day. And the obvious reasons are like increased demand-supply gap, poor sanitary conditions, and deteriorating financial and technical performance. So what can the Government of India say? It just said water is already a scarce resource and it will become scarcer. And they've turned the table and they have asked every one of us to look in for non-conventional methods of sourcing and utilizing water, which we need to practice. So, and what is the solution that we wanted to give to address this water scarcity is to trap the moisture in the atmosphere. Because moisture is the only one non-conventional and a renewable resource that is available for water. And harvesting this water from the moisture with a special equipment could be of high cost. But what we thought, an air conditioner machine that is being part of every home and corporate sector nowadays can be put into a right use of harvesting water from atmosphere. The basis of technology is quite simple, nothing rocket science, and every air conditioner machines, they have cooling coils, and when the air passes through the cooling coils, the moisture get condensed and the water comes out. It comes out of the AC machine as byproduct. And the water that comes out of the AC machine is a headache for every civil engineer. And we are concentrating on the urban air conditioning because once AC was considered to be a luxury item, and now it has become a must-need item in any tropical country or even in a developing country. It is now a sign of middle class, and the cost of an AC machine has got reduced to the cost of a two-wheeler nowadays. The cooling demands of Mumbai, one of the metro city in India, alone has been estimated to be a quarter of those of the United States, and air conditioning sales are growing 20% a year in India and China. So the best feature of our solution is this is the only non-conventional resource of pure water that is available throughout the year in the tropics, and it is one renewable resource and requires no special equipment or instrument to get it. It can be a potential and an alternate source of potable water, but after essential treatment, and it can offset the use of municipal water. And beyond water, it also saves a substantial amount of energy at almost zero energy expenditure. And this energy which we save on harvesting water from the surface or ground can be quantified in terms of carbon footprint. And you can ask me a question, will this really work? Because when you look at the AC, it's just water that is dripping out. But when you look in a holistic perspective, a complex or a corporate building which is installed with a 350 tonnage of AC capacity will produce an average of 3.7 liters of water per minute. This is huge actually. Using this condensate on site, a city can easily save 2,192 kilowatts per hour of power, and which in turns can reduce 1.15 metric tons of carbon dioxide per year. As you know, like water and energy is nexus, and to produce water, we need to spend energy, and to make energy, we need to spend water. So if we can use or trap this non-conventional resource of water, besides mitigating water and energy crisis, we can also break the amplification loop humidity contribution to the global warming and vice versa. So we did study for a couple of years as the weather drastically changes in our country. And this is a picture of one side of my lab where I've installed a small AC with 1.5 ton. And it runs for average of 8 to 9 hours per day. And it gives us 13 to 14 liters of water. Theoretically, it is a distilled water. Of course, there can be contaminants. And now we have technology where we can even treat harsh effluents. So practically, converting this AC condensate water into a potable water of world standard is quite simple and cheaper. And we did a survey across the city where I reside, and there are 1,000 public and private sector companies which are installed with 15 tonnage of AC. So the total amount of water that comes out of the AC machine as a waste can completely serve the children population, the daily drinking water of the children population across the city. So we don't have to depend on groundwater, surface water, or any water of any sort, which is naturally available. And we also continued this with other cities. And this is one site where we worked, and we started collecting AC water and check whether our theory works. And you can look at this yellow column where this particular building, they require 120 liters of water per day for drinking purpose, and 100 liters of water per day. But when you look at that yellow column, on an average, every day, we get 20% extra water dripping out of the AC machine, which can be put into a use. And this was one mission we designed with the help of a private organization, Eureka Forbes. They are pioneers in India in making water purification system. And even the cost of the prototype is just 60,000. And generally prototypes are tenfold price when you compare a commercial product. So, and the cost of treating 30,000 liters of water is less than ₹1 per liter, which is quite cheaper. And the only commodity that we get in India less than ₹1 is your mobile service, and this can be made with less than 1 liter, ₹1 cost. And we also took it to the community, and you can see here there is one building on the left side, which is a hostel. It's a government hostel for the marginalized girls who study in colleges and schools. And next to it is a shopping mall, which has installed around 250 tonnage of AC. And the water requirement for the shopping mall is around 650 liters per day, drinking water requirement. And for the hostel is 300 liters. And all the 1,000 liter of water, they simply come out of the AC machines from the complex. So we convinced the complex, and we have installed the machine there, and now the AC drain water is being treated, and it is being supplied to the children who did not have access for clean water earlier. And the real potential of the solution is like in the entire experiment, we involved around 105 tons of AC machine, and we could harvest 3 lakh liters of water from the machine, which is around 5.9 liters per hour, and we could save enormous amount of energy, as well as we could prevent carbon dioxide emission, rather spending energy on exploiting groundwater or surface water. And we could also save a substantial amount of money on spending on water. So when we imagine at a national level, in India, as of now, generally these projections are very less than the actual statistics in our country. There are 40 million tons of AC units which are actively functioning in our country, and it is all running for 8 hours a day. We are not calculating the residential component. It is just the commercial ACs that we are targeting, which runs for around 8 hours a day, and we get 208 million liters of water as of now getting wasted in the drains. This 208 million liters of water, as per WHO standard, it can feed 65 million Indian adults, and the actual population of South Africa is 64 million. So the water that is coming out of the AC machine in India can just feed, can be a daily drinking water requirement for the entire country, South Africa. So when we have a greater picture, we understand that a wastewater from one country can feed another country completely, actually. So of course, there are commercial machines available to extract water from air, but the challenge is like they eat a lot of energy, whereas AC machines, the actual purpose of installing an AC machine is not to extract water, it is to maintain the indoor temperature, but actually the waste which comes out of the AC machine is the elixir of life. That is why we are all here, actually. But I would like to emphasize that please do not misunderstand. I'm not here to advocate the use of AC machines to extract water, but to emphasize that wherever there is AC machine and we can possibly collect that water, treat it, and put it in some other purpose. So to conclude, the actual intent of this work is to evaluate AC condensate water collection potential across the country and to apply tools and techniques in generalizations that can be made regarding where condensate collection and reuse would be recommended or perhaps even be mandated. And I'm sure that days are not far ahead where the government of India will be coming out with a policy where any corporate buildings which has installed AC machines for more than 10 ton has to collect the water, treat it, and reuse it for drinking or other purposes. So we are working on that with the government of India. And I would like to acknowledge the Department of Science and Technology, Government of India, because with no funds we cannot do all these things, and they gave us 2.6 million Indian rupee to carry out this project. And another good news that we wanted to share is like this solution attracted the Ministry of Environment of South Korea, and we won the Best Solution Award for the year 2020, and they gave us some extra 10 million Korean wons to continue on this work. And now we are working on converting this AC condensate water into a distilled water, where a country like India largely depend on distilled water right from academic to industrial purposes. And if we can convert this water into a distilled water, probably we save 70-fold excess water and 10-fold energy that we are presently wasting on extracting groundwater or water from natural resources. So one thing I would like to say before I conclude, either it's a big or a small step, let's play our part. We need to start and be water smart. And I would like to stop here with one question to all our consigns. We need to, this question has to prick us always, like what will our children say if they found out we knew and we did nothing? So whatever the small or big role that we play in this environment, let us begin with us and let us be the change we wish to do. So thank you very much for listening.
Thank you, Prof. Setha. Our next speaker would be then Prof. Kenyerere. Prof, please come and join us here.
Good afternoon, colleagues. Good, yeah. My name is Thokozani Kanyerere from University of Western Cape in Cape Town. Is my presentation up there? I'm looking at the engineers at the Solution Center. This evening, we would want to share still about the technologies. So this is in the space of water education. Yesterday, I talked a lot about standardization and professionalization, and you have heard from the Deputy Minister that we were in the business of professionalizing the water sector. And this evening then, from yesterday's presentation, I'm continuing looking at the use of the technology and the methods and the content that need to be repackaged when we are providing training so that we progress. My field is groundwater, and so the case study is on groundwater. Next slide, please. Oh, sorry. And those are my colleagues on this project. This is the abstract that you have. That's what we need to talk together. So if we can read together this abstract, then we have the presentation, because the rest of coming is speaking to that. So taking it in the field of the hydrogeology, which is applied hydrogeology or geohydrology, currently taught in broad spectrum of institution and focusing on different aspects. But we need to be mindful that successful instruction in hydrogeology requires different technologies and the methods, depending on the desired learning outcomes, what we want to produce from there. So we did all those reviews, but remember on the yellow one they say, however, recent reviews showed that a growing trend of field and lab teaching approaches rather than the classroom tend to foster more skilled professional in our young people when we train rather than classroom. The argument here is that when we're providing training, it must be blended. It's good to have the classroom discussion and learning, but our young people learn better when they're out there and they do all the learning that needs to be done. So integrated and interactive, and this is to provide a balanced teaching and therefore sustain the skills accompanied with knowledge in the field of groundwater, and it will be on the other one, and therefore. And then we have concluded there. We conclude that the training in groundwater should consider using technologies and the methods combined with the content which is required in order to produce the competent people that can function professionally at a workplace. So it's a balanced skills. It's good to be content as a teacher. We must be well focused, and we must be very competent, but again, the skills required from the text. These are the 9 challenges that I spoke about yesterday's presentation, that as Africa, as a continent, we are trying to do all the exercises on all the research and all the activity in the water space. The idea is to ensure that we contribute to reducing the challenges that are ahead of us. So our AU 2023 agenda, we're saying we need to focus on those 9 challenges in Africa, and we need to be finding solutions to ensure that our continent is water secure. I also did a talk a little bit yesterday that no matter what we are doing, we must know that our groundwater and surface water, they're in constant interaction. And therefore, the chemistry of surface water, the chemistry of groundwater, the chemistry of groundwater, the chemistry of surface water, and that type of interaction, a teacher, a trained teacher in the water sector, you need to package your content, your knowledge very well, articulate the subject. You must be competent and confident when delivering this. But remember that you need techniques, you need methods that will enhance you, deliver the lesson that you want to deliver to the people you want them to understand. Coupled to that, you need technologies. You need technology. So the technologies come later, but the content need to drive that, and therefore would move well. So content first, and then the methods, and then the technology. So the simulation should be able to help us articulate what we have. When we are providing training, I stay in Cape Town, and I teach at the University of Western Cape in Cape Town. If you are teaching the water sciences, my groundwater students, I will take them to Cape Town first. I say, let's look at the Table Mountain. Let's look at the Cape Town city. You see the stadium there, the Table Mountain from aerial view. And then say you are focused on groundwater, but remember that you are surrounded by water. And then we talk about, we'll say South Africa is a water scarce country. Say, what do you mean? This continent is surrounded by oceans. Can't you visually see the physical presence of water? Which water scarcity are you talking about? So you bring students out of their classroom to appreciate the reality that there is water surrounding South Africa. So when you talk about water scarcity in South Africa, you need to define further. Probably you are talking about economic scarcity of water, turning what is available to usable, but that's a different understanding. Make sure your learners understand the context, the space, and then say, in this one now, we can go further in looking of the water that we are talking about. This slide shows or setting the scene, the context that the water students need to understand that we are not a water scarcity country physically because we're surrounded by the seas, but maybe we are a water scarcity economically because we have not set aside enough money to desalinate the water that is surrounding us to make it usable to what we have. Students need to have that context. They need that content before they do that. And then this is an example of the city of Cape Town in the drought part. So we talk, now we are setting the scene. See what is available, the content, the knowledge, and the methods. Look at it. This is the water usage that we have. 98% we use surface water, 2% groundwater in the city of Cape Town, and therefore the water is available for use anyway. And again, remember that this successful instruction in hydrogeology requires a variety of techniques and then methods, and that depending on what you want to produce the stream. So look at the dams that are feeding the city of Cape Town, and then after that one, students are out of the classroom, they're in the field, they can visualize that you're talking about because you want them to connect the content and the techniques so that when you go back to the classroom doing the simulation, they have already packaged the content in them and they can make sense of the software that we have. So this slide shows the dams that we have in the city of Cape Town, and our Cape Town is fed by that water. And then you give now the cities, a local municipality, we talked about that. So look what we have in terms of the sources, in terms of the strategy of the city. Any city to have the water, you have a strategy. So they need to be familiar with the strategy that they have. So you take them out of your classroom into the actual space to understand the strategies. And remember, you are a groundwater learners. So your groundwater is part of the different sources of water that the city is using. So students should have a broader understanding in terms of the content-wise before they start calculating, in measuring, in estimating, in modeling. They need to fit into a reality when they live. And that's the slide shows there. This, now you bring them that in type of availability in the winter season. I mean, we receive water in Cape Town in winter season. It's raining now. It's a cold, blowing, raining. So we have water. So in terms of rainy season, you will see your surface water. Then in terms of scarcity, in drought, in dry season, your surface water has gone in the subsurface because you want to introduce the content of recharge and discharge. So they need to understand that. Again, take them outside before you give them the techniques in the classroom. We are talking about packaging the three. We call it TPAC, that we talked about yesterday. Again, this is a case study that I use with my PhD student, Danica Kana, and then we say, now we go into the subsurface. Let's zero down into the subsurface and see what we have. So here we are mapping the microbiology, the chemicals, but here we're talking the contaminants in the subsurface, and see how the city, the groundwater in the city gets polluted before you introduce the content of risk and pollution in the groundwater space within the city. So you map them. They need to visualize. And I've been doing this study from 2017, and it should be finishing a PhD next year. And this is what is coming up in mapping the subsurface. So you understand the water levels, the E. coli, and all what is happening on the surface. And then you go back to your university. As I said yesterday, at the University of Western Cape, we have two aquifer systems, unconfined and confined system, and we do groundwater remediation. So we have boreholes for production. At the moment, 40% of the water that we use at the university, we tap it, we abstract it from the aquifers, and then we treat, and then we supply. And that's my master student that we're working on remediation. So again, take out of the classroom, and they bring them into the reality. They should be participating in processes, in sampling, and they understand the purification system that they have themselves. And later on, you say, this is how you learn. You package the content, you go to the method, you show them how you purify and what you remove, and then you go into the dashboard. You say, now you have understood the content, you have seen the method, see how it works now, see the simulation on the dashboard. And all the boreholes on campus, they are put on the dashboard, so they can go into the purification room look at the boreholes, and when we remove iron and manganese, you show this abstraction boreholes. Here it purifies, here it goes until it gets out. So they see the water from the borehole and through all the purification part. That in that way, you could see your students are being internalized in terms of the content. They can visualize the technology. So this is the technology you tell them, and they have the content and the method that they have learned in chemistry, in biology. You repackage together to make sense. You prepare them towards professionalization in the water space so that when they go to work, they actually do what is required to be done. Again, you go into the modeling part. Now they have seen the city. You took them out. They saw the city. You have shown them the water strategies. Now say the type of aquifers. You can see there. There's unconfined aquifer and then confined, right, moving there. You see the activities happen there, the climate change and the water level that they measure. You look at the variable that you need to do that, and then you come to there and you simulate at the end and say, before you start numerical modeling, you need to set up your simulation modeling. You should know which layer of the aquifer are you simulating and what variables do you need to see. So you work with them, and then it becomes easier to interpret the simulated variables, the options analysis, and the scenario they have developed. But they need to start right from the conceptual modeling, and then imagination, and then playing with the variables, set them into the simulation platform. Remember, you are training them the content, and again the method, and then you put in the software. So the three speaks together all the time, and in that way you are training your student towards professionalization of the sector. And then the three, we said, must come together. So the content of the subjects must be there, and the pedagogy, the methodology must be well packed, and then the technology comes a layer. Always teaching must come to display. And in this way, in the water sector, we are moving towards producing our graduate who are capable and competent to work and to fit at the workplace. So the TPAC is what we should be driving to as the T-shirt in the sector. And again, it is not as easy and straightforward as is being advertised or advocated. It has its own challenges. Some universities, so we don't have enough resources to be taking students out. The students themselves attitude, they might have their own attitude. We're entitled. As much as we start year 1, 2, automatically I need to graduate because I've registered for master's or PhD on honors. So that attitude, I automatically need to graduate without putting effort. It also kills. It's 2 minutes. Okay, and again, some teachers may not be that prepared, but we are saying, no, if you go into the field of teaching, you must be well prepared, well articulate. You must know your subject yourself before it others. So again, experience. People grow with experience, they grow with experience with time. Attitude, so there are also challenges with using that. But the message is combine the three in order to produce a good product that can sell and fit into the current market of professionalization within the water sector. Thank you, colleagues, for listening.
Thank you, Professor. So I would like to invite the next presenter, Mr. Wilfried Steve, who is going to share his insights on assessment and characterization of groundwater resources in Mawana Game Reserve of South Africa. Yes.
Good morning, everyone. Every year, many water supply projects fail around the world. Not because there is a lack of water, but because we don't know if it's there, where it is exactly, and how much is available. What I told you now, it is possible to rapidly and reliably assess the groundwater potential without drilling, pumping, or even conducting costly tests. My name is Wilfried Jomachua. I am the French speaker from Cameroon and a recent graduate of the University of Neuchâtel with a master in hydrology and geothermics. I am so happy to present to you the summary of my master's thesis and our methodology titled GRAM Method, developed as part of Nkavu Veve project, IVP, the Monkey, and the collaboration between my university and University of Zululand. Some of whose representatives are also the co-director of my work, Professor Philip Brunner, Daniel Unkeler, and Professor Vitru Mulunga Elumalai. This presentation is subdivided in three parts. First, I will present you our study area. Next, our methodology and assumption. In the end, the recommendation and improve of our approach. Now I will show you our study area. Mawana Game Reserve is the wonderful wildlife found in African Shield, precisely in the, okay, it's not working. Okay, precisely in the head of KwaZulu-Natal, watershed drainage by the river, Swan-Folozi River. In Mawana Game Reserve, we have a wonderful flora represented by the South Africa Mesic Savanna biome and the wonderful fauna composed by the local animals of impala, kudu, elephant, giraffe, and monkey veve. Now, some people think, what is the goal of this project? Why are you working about this project? Recently, we received a report of the student involved in IVP, monkey veve, and he observed the change of the behavior of these animals, show as probably linked with the drought. That is the important goal. And then, when you make the historic reconstruction of climate data combined by precipitation in blue color, evapotranspiration in red, NDVI in green, and aridity index in orange color, we identify all these droughts and have a frequency of 2 or 3 years. The bigger one fall in 2015. All these droughts impact to the spatial and temporal water availability in Mawana Game Reserve. But it's not also this one, but the well-being and the survival of this animal. That is Mawana Game Reserve. This drought is not limited to Mawana Game Reserve. It's affected South Africa in general. Many radio stations and local and international channels talk about this drought. The bigger one fall in 1982. And then, our challenge. Context of Mawana Game Reserve, semi-arid region. Next, the limited data field and logistic. And our goal is to develop the sustainable methodology adapted to Mawana Game Reserve context and propose the sustainable solution to supply this animal and the recommendation for the reserve manager. Now, some people talk, if I don't have I have a limited data, logistic data limited, how to get it? It's very easy. I am an hydrologist. I'm focused about hydrology skill and knowledge. Assumption. Some people in this room think it's very easy. I can make water challenge and channel water balance, but it's not possible with Mawana Game Reserve context because it's semi-arid region. Evapotranspiration is every time more than precipitation. And then small error about this parameter make a lot error about the research computation. Next, when I make the tracer test, you can see the circular thing. You have a lot of, the tracer is delayed and partial absorbed. Another reason is it's very difficult in Mawana Game Reserve to identify all the input or the output of the river system. Then we'll think to make a very good, appreciate methodology titled GRAM method. J for GIS, R for remote sensing, A for chemistry analysis, and M for modeling. The first part of our methodology is combining GIS with remote sensing, represented by the script of Guillaume Attard. Focus on the turn-weight matter method titled Water Balance. 30 years after, is simplified by Senley and Van der Mullen. Now, we have a lot of input, and then you can have a value of the mean annual effective research that will be our input of modeling. Now, some equation exists before. is very difficult to identify the error, but with the evolution of technology, such as automatization and intelligence and artificial intelligence, and allow us to detect this error and modify the equation, can paving the way for the critical review of certain hydrology model. These two errors can change. And then, all these equations do not involve the site-specific parameters such as geology, geomorphology, drainage network, and other recharge on the site. Then this recharge on 103 millimeter per year is the overestimation of the actual recharge. The modeling is important to involve all these parameters and have a very better evaluation of recharge and aquifer parameter. The modeling is focused on HydroModPy, developed by one student of my university, focused about the dimensional ratio, conductivity per recharge to evaluate the hydroconductivity in steady state and calibrate the recharge. We have two values of recharge, and they can explain the climate change over 2000 and 2023. In a transient system, we can calibrate the porosity and evaluate the water potential. Now we have two ideas. First, the parameter of an aquifer and the water potential. The next one is what? Where is the water? It's very important to make a potential of water map. And then in South Africa, Professor Vitry suggests me to make a EHP. What is it? This map. If we combine these two maps, we have the EHP developed by Thomas Sahati in 1918. And what is the precision? Around 19%. And then if I want to suggest for the reservoir manager, where is very important to build and install the well, it's very important to install the well where we have the blue color, where is the higher potential zone, and you can mitigate the climate change. The next one is chemistry analysis. Now we have water. You know, where is it? It is possible to drink this water because some people come to Mawana Game Reserve and have the pleasure to see the animal, to pass the time with her family. This water is very drinking to her family or not. Now we use the chemistry analysis. The chemistry analysis allows us to have a better comprehension about how water travel around the world in the surface or under the ground, first. And to validate our assumption we introduced in remote sensing and modeling. And the end, to have the information about the rock, because Mawana Game Reserve is very wonderful with life, but we don't have the previous data. This work is the first work in Mawana Game Reserve, and then we don't have data, but we can flex about our ID skill and knowledge, hydrogeology knowledge. Water have the memory. If you throw the water here, you can have all the information about how this water throw and which type of rock is thrown. I think I talk in good English. And then I have the isotope. Isotope graph. Isotope graph told me about where it comes from this water. All this water comes from mainly by the groundwater. And the rest on top of this graph is the sample in the pond or the river flow very, very slowly. Then this water is exposed to evaporation. And then the value of heavy isotope is high. Then when you focus about the South African standard, show us SRN 241, we can tell us the water flow in Mawana Game Reserve is acceptable to drinking, human or animals. For the next is the recommendation. If I want to give some recommendation and future improve of our method is to add anisotropic and heterogeneous for the model, to make a chemistry analysis, very regular interval, to water quality, made the microbiologics and heavy metal for contaminant, And the logistics have a long-time recording to have a better influence about the river and her influence our discharge and recharge aquifer, and it's possible to use this method for another seat. Maybe I have a lot of log, all the data conveyed in the same point. If you apply this method in another place, maybe you can have a good data and you can give the good value of our methodology titled gram method. And in conclusion, with the little data on the seat, it's possible to have information about an aquifer, property, and potential. If you respect all the initial conditions, you have a lot of water to supply this animal, and the water table is acceptable for consumption, human and animal. The impact of climate change is mitigated with the pumping well, manual or of motorized, and our gram method is reliable to have a decision-making and sustainable resource management, limitation protection zone, and territorial planning. Thank you for your attention.
Thank you very much, Mr. Wilfred. Our next speaker, we will take questions afterwards because we would like to try and get all the presentations just done. So our next speaker, Mr. Nyawo, please. Just watch the time, otherwise I'll warn you if there's 2 minutes left.
Okay, no problem. Good evening, respected colleagues. It's my honor to stand on this podium before this accomplished audience of global scientists and researchers. I'm Siboniso Ketanyawo under Professor Vetri's supervision. So today I invite you to join me in this presentation, which will be based on global comprehensive review on subsurface water contamination and the dynamic hydrogeochemical processes, which is a perspective that is based on nutrients and trace metals. So the first point here is about to know what is it all about, subsurface water. Subsurface water is more of groundwater that is non-frozen, which exists within confined aquifer, unconfined aquifer. It also exists in unconfined aquifer and piezometric level. So this water flows through salt particles and through rock fractures, which may allow it to appear as a big spring. But sometimes this water can appear through borehole drilling. So an up-to-date information suggests that 50% of this water is consumed through drinking purposes, and 40% of it is used in agricultural landscapes for irrigation purposes. But we have a problem of this subsurface water course, which is contamination that can result many negative feedbacks in our global scale, which can cause groundwater contamination that can lead to human health risk issues, and also decrease our land values from agricultural landscape, which can affect our global economic. So with this review, we aim to identify current sources of these nutrients and trace metals contamination in groundwater with a special attention of affected regions at an elevated content, and also examine how this contamination is influenced by the hydrogeochemical processes to see their distribution and their mobility in the vital zone. So this is the method I followed to have the data regarding the concentration of 2 nutrient parameters I considered and 5 highly linked trace metals that are carcinogenic in groundwater. So there is the flow type, which is Prisma, I showed there how many number of papers I've considered to source the data. And also that concentration, I was looking at the mean concentration per each region in reference to World Health Organization thresholds. So then I used ICEES Pro to localize those regions that are experiencing the contamination at a highly mean content. Then I've also showed there some of the softwares I've used for this review. Also, the mapping of keywords I've utilized to source some of the articles and papers. So, what you need to know first is the sources of these nutrients and trace metals. So, starting from nutrients, they may be both sourced from geogenic and human-induced sources, which are anthropogenic activities. So based on the geogenic one, we can see on the slide that the mineral deposits, they play a pivotal role to release nitrates in groundwater, but in minor content, because majority of this nutrients concentration is released in subsurface water due to agricultural practices. As I mentioned, there's some of the human-induced sources that release the nutrients in groundwater or subsurface water. So for phosphate, the orthophosphate rocks, they play a pivotal role to release these nutrients, this concentration in subsurface zone. So I have shown there a pie chart diagram which have a global perspective of in statistics way that shows that in agricultural landscapes, they really contribute high concentration of these nutrients in subsurface zones. Followed by the trace metal. When we come to trace metal, it's different because trace metals, they are mostly released to the subsurface water due to the geological formation that is different between these regions. As we can mention one of the highly ranked trace metal, which is arsenic. So mostly this trace metal is released from the oxidation of arsenopyrite rocks or mineral ore deposits. So I've also stated some of the averaging concentration that is continued from these rocks about these trace metals. You can see there on my flowchart that chromium is mostly sourced from the ultramafic and mafic rocks, which are igneous rocks that may be appearing due to decadal or volcanic eruptions. Also, I've also mentioned there on my pie chart that these are highly ranked mineral ore deposits that can release each trace metals into groundwater. As you can see also, cadmium. In fact, there are 3 dominant trace metals which are released by ultramafic and mafic rocks into groundwater, which is chromium, cadmium, and lead. But mostly lead is mostly sourced from human-induced sources into groundwater. So in the figures you can see there, these are igneous and sedimentary rocks that shows the concentrated level of cadmium in those rocks. And from the sedimentary rocks, which is limestone and bentonite, are the ones that are too much concentrated with this cadmium concentration, which can be released into groundwater through various mechanisms, of which I'm going to discuss them. Okay, now going to the worst scenario. Now I checked this method to see those regions from different continents that if we check this concentration, which are those regions that are highly affected with maybe these nutrients. So, judging to the current matter of nitrate, I observed through the data I sourced that the Southeast Asia is mostly affected by nitrate in subsurface water. Why this one is occurring there is caused by the high volume of nitrogenous fertilizers that can leach into groundwater. And up-to-date information has revealed that the two countries in Southeast Asia, such as China and India, they highly use high volume of nutrients in agricultural activities for their crop production. So these nitrogenous fertilizers, they leach into the subsurface water to cause the contamination. As you can see, majority of the Indian regions there in my figure A, I mean, majority of the Indian and Chinese regions, they are highly surpassing the mean concentration of nitrates. To validate these opinions, the assessment was further done in African regions, such as in Tunisia, Madagascar. So then the Madagascar region came with another perspective, which showed that the impact of landfill sites that caused high amount of nitrate in subsurface zones. As you can see also, phosphate agreed with this pattern of nitrate in groundwater about highly affected regions in Asia. As you can see, Bangladesh, unfortunately, there is no specific threshold about phosphate in groundwater or drinking water. I can specify like that. Coming into trace metals as well. Now, trace metals, they've also indicated that the Southeast Asia and some parts of African regions, they are also affected about these trace metals I've considered for this review. So where is the cause coming from? Such as arsenic in South Asia. This arsenic is coming from the oxidation of arsenopyrite, as I mentioned earlier. Majority of the geological formation in Asia is consisting mineral ore deposits that are concentrated with arsenic in groundwater. Also, the free oxyhydroxide, the iron ones, that are dominating in arsenopyrite, they maximize the concentration of this arsenic in subsurface water. So, judging to these separate other trace metals, lead, chromium, and cadmium, mercury as well, in this region, in these continents, they've also showed an extremely surpassing mean concentration in the subsurface zone, which is mainly caused by the poor wastewater disposal from industrial activities of automobile and also the coal mining industries. Like the furthering to cadmium and lead as well. In Kenya, Kero Valley in Kenya and Tamil Nadu, it has shown that also agricultural activities, they also have an impact to cause high mean concentration in groundwater in these regions. So I've mentioned there's some of the possible drawbacks people who are living in those regions may experience, such as kidney failure and brain damage as they are consuming this groundwater from those regions. So now I've summarized some of the hydrogeochemical processes that may cause facilitation of these or capacitates these trace metals and nutrients in groundwater, such as the pH-induced desorption. Okay. pH-induced absorption and desorption and pH-competitive ion exchange. In this context, the phosphate plays exhibit high desorption in groundwater as compared to nitrate. Why? Because nitrate depend on the biological controls of heterotrophic and eutrophic bacteria. And these bacteria, they require some enzymes to facilitate the oxidation of, or oxidation and desorption of nitrate, such as the hydrazine synthesis. So this nitrate is also facilitated by ammonification and nitrification. Why ammonification? Because ammonification has three prefatory processes that undergoes there, which is phe-ammonox and MN-ammonox, also sulfate-dependent phe-ammonox. So that's the process that drives the chemistry of nitrate in groundwater to be capacitated. As I showed in some of the figures there, the process, how it goes. So same as trace metals as well, they undergo the same process, but with the presence of denitrification, not ammonification and the nitrification processes. So for the redox potential, arsenic is the one that has higher redox potential as compared to other trace metals, which means it dissolves very fast in the subsurface groundwater, depending on the iron aluminum and manganese hydroxide. So in conclusion, just to summarize, the Southeast Asia and some parts of African countries, they experienced an elevated concentration of the considerable nutrients and trace metals I've used. However, nitrate and lead, they mostly depend on the anthropogenic activities that reduce their concentration in groundwater. But the separate trace metals, they were caused by the domination of geological formation depending on sedimentary and metamorphic rocks, mainly depending on some of the hydrogeochemical processes, as I mentioned them earlier. So I've recommended one point about this special issue, that maybe to understand the oxidation of these nutrients and trace metal, we should try to identify their age in groundwater in order to understand the oxidation kinetics. Someone can ask why I'm saying this. It's because we don't know how long it takes to stay there. Thank you for listening. It's my pleasure. Thank you.
Thank you. So I would like to invite the next presenter, Dr. Guillermo. Is he or she here? Oh, sorry. So he'll be here to share his insights on the traditional and sustainable economy of indigenous communities. Please.
Hola, buenas tardes. Mi exposición va a ser en español y bueno, voy a hablarles sobre un pueblo originario que aún vive en México, de una cultura que todavía está vigente. Se encuentra en el norte de México, en dos estados, en el sur de Sonora y en el norte de Sinaloa. Esto es importante mencionarlo, dado que se encuentra en una región altamente productiva de agricultura. Donde nació la Revolución Verde, ahí es donde está este pueblo originario todavía viviendo. Esa revolución verde que en los años 40, 50 y 60 se decía que iba a quitar el hambre del mundo, ahí nació. Ahí estuvo Norman Borlaug haciendo sus experimentos en el trigo. Entonces, la importancia de cómo de una revolución verde que transformó la agricultura, hoy ahí mismo sigue habiendo un pueblo originario. Bueno, habría que empezar entonces diciendo que si ahí nació la Revolución Verde y viven pueblos originarios, pensaríamos tal vez de una riqueza económica, una riqueza de bienes, de servicios. Sin embargo, estos pueblos originarios, particularmente los mayos, se caracteriza por pobreza, marginación, falta de oportunidades, migración. Asimismo, bueno, esta investigación la tratamos de enmarcar en lo que se ha llamado el buen vivir, como una cosmovisión integral. Sin embargo, cabe mencionar que ellos también tienen una cosmovisión del mundo, la cual mencionan como la gran verdad, la verdad de los ancianos, que cuando nosotros la analizamos nos damos cuenta que se parece mucho a lo que es el llamado desarrollo sostenible o sustentable. Entonces, parte de lo interesante sería que a veces en estos pueblos originarios también tienen conceptos, también tienen formas de llamar algo que aparentemente estamos inventando o estamos descubriendo cuando ya existía. Ahora, lo otro es tratar de promover un desarrollo con base en la identidad, la cultura y la sostenibilidad de este pueblo. Bueno, ya lo decía, tratamos de partir de lo que es el buen vivir, la economía tradicional, orientada al autoconsumo, la solidaridad, la sostenibilidad y la reproducción cultural, asimismo como el rechazo del paradigma capitalista hegemónico que apuesta por economías biocéntricas, cooperativas y territoriales. Creemos que por ahí nuestro trabajo puede contribuir a alcanzar este tipo de economías. Bueno, también entonces hablamos de principios con economía solidaria, el rol de la identidad cultural y la sostenibilidad económica y ambiental como las cosas a donde queremos avanzar. El objetivo entonces es hacer un diagnóstico para analizar la sostenibilidad de las prácticas económicas tradicionales de este pueblo y explorar las oportunidades y desafíos para presentar una propuesta de una nueva economía, pero construida con ellos y para ellos. Bueno, la metodología tiene un enfoque cualitativo, etnográfico y participativo, porque nos permite captar la perspectiva cultural interna, los valores y lógicas propias de la comunidad, así como la participación comunitaria. Y dentro de nuestras técnicas destacamos las entrevistas semiestructuradas, la observación participante, así como la revisión documental. Hicimos un muestreo con bola de nieve, donde hicimos una inclusión progresiva de actores comunitarios claves, y los instrumentos, bueno, fueron cuadernos de campo, fotografías, mapas, grabaciones. ¿Qué encontramos? Pues lo primero era tratar de definir a qué actividades económicas se dedican, y la primera es la agricultura y la ganadería, después el comercio, la industria, pero una industria local, elaboración de alimentos tradicionales, como pueden ser los quesos, algunos dulces, alimentos tradicionales, como puede ser un alimento llamado, es carne seca, carne de res seca, machaca, y bueno, también reciben remesas. Para México este es uno de los recursos importantes de la gente que trabaja en Estados Unidos y manda dinero a familiares en México. Bueno, entonces podríamos decir que es una economía diversificada, sin embargo, hay una alta dependencia de la agricultura y la ganadería. Ahora, respecto a los niveles de ingreso y la distribución del ingreso, podemos decir, ya lo decíamos, pues que es bajo, el 95% así se consideraría, y prácticamente no existe alguien que tenga un nivel de vida alto, de acuerdo a lo que el gobierno mexicano y el INEGI y demás caracterizan como tal. Y bueno, la distribución pues puede ser que es equitativa en un 80%, y porque vienen de varios fuentes, pero también habría que señalar que estas comunidades a un lado tienen grandes capitalistas que se dedican a la agricultura, mientras que para ellos pues no es así. Sobre los gastos familiares, habría que decir que el mayor gasto que hacen es sobre la alimentación, el 80%, Y tal vez el otro que habría que descartar pues, es la educación y la salud, con un 5%. Sin embargo, aún estando en un valle agrícola muy importante, aún teniendo cultivos como el maíz de manera extensiva, el trigo también, arroz, hortalizas, mucho de su alimentación está basado en productos empaquetados, en productos que compran en supermercados, no que cultivan, no que cosechan. Bueno, sobre inclusión financiera, que era otro de los elementos que nos interesaba conocer, pues casi nadie maneja las cuentas bancarias, tarjeta de banco, una cuenta en el banco, más bien hay créditos formales también es mínimo. Entonces, en general, todo lo que le podríamos llamar inclusión financiera es mínima. Sin embargo, cabe destacar que el actual gobierno ha impulsado los llamados bancos del bienestar, donde hay sucursales de bancos que se ubican en estas zonas, pero que realmente no son tan usados por esto que estamos comentando, aunque muchos de sus apoyos los reciben pues en una tarjeta que el banco les da, que el gobierno les da, pero bueno, esto es prácticamente nuevo para ellos. Bueno, entonces, ¿qué desafíos económicos enfrentamos? Pensamos que son 4. El primero sería fortalecer la economía tradicional y la autosuficiencia. El segundo, consolidar independencia del mercado para una integración plena y apropiación de mecanismos de mercado. Asimismo, recrear una nueva cultura económica a través de la cooperación, la identidad y la sostenibilidad. ¿Qué concluimos de este primer avance o este primer acercamiento? Que la economía Mayo Lloreme ofrece alternativas sostenibles propuestas por ellos, ya les decía, enmarcados de lo que ellos consideran la gran verdad, su cosmovisión de ver el mundo, requiere combatir tradición con modernidad y también la apropiación crítica del mercado es clave. Finalmente viven en un mundo capitalista, viven en un mundo donde la agricultura, principal actividad de su alrededor, es para exportación, principalmente al mercado de Estados Unidos, mercado de China, mercado de Japón. 99% de esa producción es para estos mercados y sin embargo lo que ellos realizan, pues decíamos, es más bien lo poquito que hacen de autoconsumo. Y también proponer una nueva cultura económica con base en la cooperación, en este caso con instituciones como las universidades que estamos ahí presentes, que somos 4. Una es la Universidad Autónoma Chapingo, la Universidad Autónoma Indígena de México, la Universidad Autónoma de Sinaloa y el Instituto del Valle del Yaqui. Y bueno, ¿qué recomendaciones podemos hacer de lo que hemos visto o qué sigue? Pues primero ampliar este estudio a otras comunidades de la misma región, analizar impacto del cambio climático y políticas públicas, que es uno de los temas que se han visto aquí, de cómo ha impactado el cambio climático a las diferentes actividades que se realizan y sobre todo la agricultura, pero también diseñar estrategias de inclusión financiera y integrar a la juventud en la preservación económica y cultural. ¿Por qué? Porque tenemos, mostraba en el mapa inicial, la frontera con Estados Unidos a nosotros nos queda alrededor de 6 horas de camino en carretera, lo cual implica que mucha gente migre a Estados Unidos y bueno, además o a la frontera, ciudades como Tijuana, Nogales, Ciudad Juárez, para buscar otras oportunidades. Entonces, estos pueblos originarios, su juventud tiene esa inercia de emigrar. Gracias por su atención.
All right, ladies and gentlemen, I am going to allow, we've tried to rush through it, we are so late, it doesn't matter. So, is there any questions that you would like to pose to any of the presenters? Then I'll take that and we'll try to keep it short, otherwise I'm going to conclude the session. But any questions? Just, if you do have a question, just give me an indication to who you are addressing that. Any? I'm going to be quick. Going, gone. It's dinner time. Thank you very much for your patience. Much appreciated. Thank you for all the presenters. Much appreciated.